Hi, how you guys doing? So, it's been a busy day, huh? How about that keynote? It's awesome, right? So, my name is Ray Cromwell, and what I want to show you today is two things. One is if you're a GWT programmer, an existing GWT programmer, and you've done apps before, I'd like to try to show you a new way of doing GWT applications that you may not have thought of before. And if you're not a GWT programmer, and maybe you're just a programmer using LAMP frameworks and hand-coded JavaScript, I'd like to show you an interesting way to use GWT that might, influence you to try it out. So, first, before I begin, let's kind of discuss where web applications have come and gone. Let's look at the history. So, Web 1.0 basically was about server-side round trips. So you designed a Web 1.0 application, every time someone clicked on anything, it did an HTTP request, it went to the server processed some UI state, maybe did some logic on the back end, and then it re-rendered the whole page, shipped down a big mass of HTML and CSS and images. And that worked pretty well, but the problem is that it has a lot of latency in there. So the experience is not that great. And then what people started doing is they started writing, once JavaScript kind of became powerful and faster, and people started to take it serious as like a real language and not just something to validate forms or something, is they started writing large applications, like Gmail, like Google Docs, these large monolithic applications that sort of mimic the desktop experience. And one of the features of these applications is they really don't ship any HTML down to the application after it's been initially loaded. So you load up the HTML, maybe it sets up a structure, you download a very large amount of JavaScript, and then everything else is done with REST requests on the back end, and the JavaScript modifies the DOM from that point forward. However, that model is not for everyone. That model works really well for an application like Wave, which is an incredible application where it really needs to do that. But a lot of applications that people have built, like in the enterprise and for the web, are built on the model of page reloads. And that's great. So what people are doing these days is they are going back to their Web 1.0 applications, and they're adding a little bit of JavaScript here and there and gradually making it more Web 2.0-y, if I can use that word, by eliminating page reloads and using AJAX REST requests on the back end. And that's sort of like the predominant model you see nowadays in a lot of startups. There's also kind of been a return to simplicity. So if you remember what happened during the dot-com era is, Java got really popular, and people started building these monolithic frameworks, and they just got bigger and bigger and bigger. And it kind of culminated in J2EE, where to write something really simple like a hello world, you had to write like 10,000 lines of code, a boilerplate. And people kind of rebelled to that, and the first rebellion was to sort of pull back, and you got things like Spring, where people said, I only want IOC containers, I only want dependency injection, I don't really need all this extra stuff. So you got like Spring and Hibernate, and that worked really well. And then it's been kind of simplified further because a lot of times people don't even need that, so you see with Rails and the Django this active record pattern where people just generate a skeleton app, and it's very simple, like objects are directly mapped to the database, and they spit out HTML from PHP, Python, or Rails. And it's very, very simple. Your code base is small. You can get it up and running in like 5 minutes. And usually what they do when people do these applications is they first sort of get it working with HTML without JavaScript. So like your application will work even if JavaScript's disabled. And then they go back and they sort of add on top of it HTML to make it more client-side interactive. So the page reloads are gradually replaced. So essentially the key thing is that logic from the server that used to deal with UI is gradually pushed to the client. And the way people do this nowadays, they use popular JavaScript libraries to sort of walk them through it, like jQuery, Dojo, Prototype, MooTools. There's like a bunch of them, and they're all great. My perspective, which is not necessarily the right one, but as a GWT developer, I don't like the fact that the end-to-end tool chain is not coherent for me. Like in other words, if I'm doing Rails or Python on the back end, I have a different set of tools. I'm using Rake or something else to basically build and configure my app. And then when I get on the client side, it's different. So how I unit test is different, how I check the app for errors or inspect it, run inspections and things like that. It's all different. And I kind of prefer to have an end-to-end solution that works on both sides using the tools that I'm used to. So basically what I've done is I've built a library that allows you to do what people do with libraries like jQuery and Dojo and Prototype, but I've done it with GWT. And if you are not familiar with GWT, and I hope you are familiar with it, basically, to me, it's a really kick-butt optimizing compiler and hosted mode browser tool. And it produces incredibly fast code. I mean, I'll show you something later about some of the code it generates, and sometimes it even amazes me. It reduces startup latency a lot. It produces very small code. It reduces, most of the time you can reduce all of the HTTP requests in your app down to just 2, and sometimes just 1. It integrates with all of the Java language tools that you're used to, your IDEs, IntelliJ, Eclipse, Maven, Ant, for build tools, your continuous integration tools, JUnit testing, check style, find bugs, all the tools you're used to with Java that are mature, they've been around for 10 years, they just work, and now they work on your client-side code. However, if you're in this room today and you're not a GWT programmer, it may be a big leap for you. There is, I'll be honest, there is a learning curve. If you're like a JavaScript programmer or you're doing, you started with Python or Ruby, it's a pretty big leap. And also, rightly or wrongly, the way GWT is currently constructed, the library, it sort of encourages people to make these desktop metaphor applications using widget abstraction. So it kind of encourages you to build something that you would build with like Swing. It encourages monolithic applications that don't have more than one page. And there are times to do that. That's actually a perfectly valid reason, as we saw with Wave and with Gmail and Google Docs. But there's a lot of other applications people do where multi-pages are a good thing. And the other problem is that the learning curve for UI designers who are going to make your site look good would be pretty big for them to start writing all of their code using GWT widget abstractions. They want to deal with HTML and CSS because that's what they know. So it could conflict with your existing design process in your company. So let's talk about progressive enhancement. So it's different in every company, but in some of the companies I've worked in, the way the website starts out, besides the defining what the requirements and use cases are, is that a designer will sit down with like Photoshop or some other tool, and he'll mock up what the UI will look like. Sometimes it's like an image or some other tool. And he'll show it to everyone. Everyone will sign off on it and say, hey, this looks great. I like the way this looks. Now we want to make it into a website. And then they'll hand it to some guys who know how to code. Sometimes the designer and the coder are the same if they're lucky. I'm not one of those people. I'm really bad at UI design. They'll hand it to a coder, and he'll take that design from Photoshop, and he'll slice it up, and he'll reify it into like HTML and CSS, and he'll make the code generate what the designer had in mind, typically using like PHP or Python or Rails and things like that. And you'll end up with a working Web 1.0 application. You click on something, and it goes to the server, and it runs another PHP script, which outputs the website, again, with all the template and nice UI design stuff on it. And then after that, the guys will say, hey, let's start trying to make this site more dynamic. Like, maybe when I'm paging through like an enterprise report, rather than reloading the page every time, I'll just launch off a REST request to the server on the back end, get the data, and then I'll just repopulate the DOM without leaving the page. So they start to enhance the existing UI by layering JavaScript on top of it. But the cool thing is that if somebody comes to the page and they don't have JavaScript turned on, the app will still work. And there are places where people do that. I believe in Japan, a lot of the mobile phones actually don't have JavaScript. They just have HTML support. And also, it facilitates SEO, search engine optimization, and accessibility. So, the search engine sees your app. If it doesn't understand JavaScript, it still sees the HTML content, so it can index it and find it. So here's an example of how someone would progressively enhance something. This is would represent the output of an RSS feed reader. So you've got like a container element, and you've got a div with class equals article. So you've got 2 articles, and then you've got like a h3 element with a title, a p tag with class equals summary, which is the summary of the article, and then like another p tag, which is the entire body of the article, which would be quite large. And then a bulleted list of ULLI, which is the possible actions you could take. Like maybe you're going to leave a comment, or maybe you're going to do a trackback. And what you want to do is you maybe want to enhance this a little bit. Maybe like you don't want to show all of the body material expanded right away. You want it to have it collapsed. And then like maybe when you click on something, it expands it to read it. So here's how you would do it in jQuery. So someone would write this little snippet of code. They'd say, find the body that contains all the content using the CSS selector, .article.body. So find the div, find something that has a class equals article, find something that has the class equals the body, and call hide. Now what hide does is it sets display : none. So it basically hides the element, so you can't see it anymore. Then the next thing they might do is they will say, I'm going to add a new action to that list of where it says comment and trackback, which is like read the article or expand it, so now you can see it. So they say, find the container tag, then find the article element, and then find the UL element. And I'm going to prepend an LI as the first child of that UL, and it says read the article or read body. So it's a link. See that A link up there. Now they have to add something to handle that link. So what they do is then they write another bit of code which targets that A link that they just injected. And that says, OK, find any action with an LI element that's called read body that has an A link in it, and add a click handler to it. And what the click handler does, if you can see it there, is it says, OK, find the parent UL element of this LI, find the previous sibling, which is the body tag. It's a sibling of the UL tag. It's kind of walking up the DOM, and then toggle it. So that's going to make it be shown. So I'm going to show you a quick example of what that would look like. This is actually from the jQuery tutorial. OK, and I'm going to scroll down. Well, maybe I need to resize my browser a little bit here. OK. So I'm going to scroll down here, and here's what it would look like. So here's in the browser, and after you execute that jQuery code, I click that read body, and it expands the content. So that's what we want to do. We've progressively enhanced the page to make it just a little bit easier to use. So before I go on, let me discuss the core jQuery concepts. As I see them, this may not be how the people see them, but this is kind of what I infer from it. Number one is querying. So instead of using DOM methods to navigate the DOM, like get elements by tag name, get for child node, get first child, get next sibling, and so on, which is really painful, you write a CSS selector query. The library executes it, finds all the elements that match it, and then basically then you perform a bunch of operations on it. And the way you perform those operations is by chaining method calls. So you could say, OK, find me all the div tags that have class equals foo, and then set its background color to be red, and add this event handler, and change this attribute of the thing. And you can do multiple operations just by chaining. It also provides a pretty powerful set of functions to manipulate the DOM, to inject content, to remove content, to wrap content, to just move stuff around. And they're really powerful, much more powerful than what you get in the basic DOM level 2 interface. It provides a facility for attaching arbitrary data to any element, and also attaching binding event handlers to elements. And finally, probably the biggest thing that to jQuery's success is that it has a really, really simple way to write plugins for it. So people, after they write things, like the thing you just saw where it kind of modifies that feed reader output to make it collapsible, they would change that into a plugin, maybe call it the feed collapse plugin. And then they'd publish it somewhere, and people could just include it. And then with one line of code, they could just apply it to their feed. So it has a really nice way of doing plugins. So what's jQuery? jQuery is a jQuery clone written in GWT. So it's written in Java code. It's compiled to JavaScript. But it's designed to fit in the sort of workflow that people who do progressive enhancement on Web 1.0 applications are used to. And I've tried to make it easy to learn for people who have used jQuery. So the syntax, maybe surprisingly, doesn't look like Java. It actually looks like JavaScript, but you're actually in Java code. However, you do get a benefit, is that underneath all of that code that kind of looks like it's not even Java code, it's actually being type checked. You get code sensibility pop-ups, Javadoc pop-ups, and all the other benefits of GWT, which I'll show you. So here's an example. This is legal Java code. Sometimes people are kind of surprised when they see this because you usually don't name a function $. But Yes, there is a function called $sign in my library, and it's statically exported, so you can import it at a top level, and you just refer to it as $sign. So what this code would do is it would find all of the div.menu items in the current page that this is running and set their vertical align property to top. Now, what's interesting about this is that I'm not doing quote vertical dash align quote comma quote top quote like you would do in jQuery. In actuality, what these are type-safe enums. And the interesting thing about this is that the IDE will make it impossible for you to type a combination of CSS property name and value that are invalid according to the CSS spec. It will do it at edit time, and it will also check it at compile time. But more than that, it can also show you a pop-up of what the legal values are, and even JavaDoc taken from the CSS2 spec or from the Quirks mode database. So as an example, I'll bring up my IDE just to show you what this experience is like. So let's say I want to set a CSS property on this. I'll type in CSS, and then I'll hit my completion. And you can see vertical align is one of them. I think I got to double do it. Let me try this background. Did I not? Maybe I didn't import something right. Okay, yeah, that's why it's not seeing it. Oops. My IDE gets too smart sometimes. Okay, now it should work. So there you go, background color, display, width. You might say, okay, if I put the display property, what are the possible values? Oops. Block, inline block, and so on. And in fact, you can even hit JavaDoc, and I can see from the CSS2 spec like what each one of these will do. Because you might not use the run-in or the inline block display property very much. You might not remember what it's like. And this is nothing. I haven't done anything to my IDE. There's no plug-in to my IDE. Any IDE will show this because it's just a property of the Java code. It's just JavaDoc. So another example is, for example, this vertical align property takes not just top or bottom or baseline and those kind of things. It actually can take a value. So I can go here and say, well, okay, I can put in middle, baseline, stuff like that. But I can also put in a length, like 10 centimeters. So what happens is the IDE knows that the vertical align property can take one of these enumerated values, or it can take centimeters or some other length value. But it can't, for instance, take a color. So if I put something like this, RGB, like blah, 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 it's an error. You see it's red. So it knows that vertical align does not take colors. So it basically makes it harder to make a mistake. Oops. Okay, so let's go back to the presentation. So there's other benefits to using types, and this is where the GWT compiler comes in. The compiler has various optimizations in it. One of it is called type tightening. And the compiler can actually see what values are being used sometimes and whether or not there's any other alternative. So the compiler can infer, in this case, that I only use the top property and I only use the vertical align property name. So what it did is when I compiled it, it eliminated the CSS routine. And it eliminated all the other properties that you might set. And it just inlined this loop, which is for I equals 0 to I list the number of elements that have been matched. Set this element.style property vertical align equals top. So basically, it removed everything else from the program except for that and inlined it. You can't write faster code than that, even by hand. There will be no JavaScript code you can write that will execute faster than that. So just another quick example. Can anybody see anything wrong with these lines of jQuery code? There's some subtle errors in here. So the first one might be a little bit obvious if you're looking at it. Background color is spelled wrong. So if you actually wrote this code and you execute it in your browser, you won't get an error. I think in Firefox, if you look in the error console, you might see it. But in many browsers, you won't actually get any error at all. And if it's something obscure, like some background color or some really tiny element somewhere, you might not ever even see it. You might deploy it to production, and you'll never know unless somebody, later on, a week later, says, hey, this color didn't get set properly. Second line, lavender is not a system color. So there's a whole bunch of CSS2 system colors like, magenta and cyan and stuff. Lavender is not one of them. The next one is kind of interesting. Maybe you're running a CSS selector, with an ID selector, and that element might not exist in the page you're targeting. It'd be interesting to get a warning when that happens, like you wrote a CSS selector and it doesn't match anything. The next one's kind of tricky. Can anybody guess what's wrong with that one? So it's binding a callback event handler for the double-click event. The problem is it's called DBL click, not double-click. So I think that's, could be an easy mistake to make by some people. The last one I'm going to leave for an exercise to the reader. So later on, you can go and download the presentation and see if you can figure out that last one. Okay. So like I said earlier, because it's Java, you get to use all of your normal JavaScript tools, Java tools. So you can do JUnit tests using your IDE. Here's an example of me running that div.menu and setting the vertical line top property. And then I have a little loop there where I loop over the same selector and assert that the actual elements had their top properties, the vertical line property set to top. And then, of course, you see a little pop-up there from my IDE. I can just run that right in my IDE and check it right then and there, or I can run it at build time. There's some other cool stuff you can do with jQuery and unit testing that if I have time, I'll talk about later. So now I'm going to show you a quick demo of progressive enhancement. Here is some HTML that's basically just 2 div tags with some bulleted LIs in them. And that's all. And what I've done is I've written a little bit of Java code in jQuery, and I've turned it into sort of like a PowerPoint-like slide. I transitioned to another slide there. So if you don't have JavaScript enabled, you'll still see the information, but if you come with JavaScript enabled, you'll get something that kind of looks sort of like a PowerPoint presentation. So the cool thing about that is that if I go to that website, so this is deployed on App Engine, and if I open up Firebug, let me see this. Okay, here's the generated JavaScript. So it's compiled and it's obfuscated. You couldn't read this and figure out like what it's doing. So you might need to debug this. Now this is deployed to production. So this could be like an app that people are using. It's been in production. It's been reliable for a while, and you might need to check on some bug that you suspect is somewhere. Well, GWT has this thing called hosted mode, and what you can do is I can attach a Java debugger to that HTML site. So I'm going to click the debug button up here, and I'm going to launch hosted mode. And it's going to take a second. You can see it's connecting to gwtquery.appspot.com/demo. So I'm loading up HTML and JavaScript here. And there it is. You just saw it. But I've got a breakpoint set in my Java debugger when I click on something. So I'm going to click the mouse button. And you can see that my breakpoint triggered inside my Java IDE, but from a production compiled and deployed JavaScript site. And I think that's pretty cool because I can step through this and try to figure out where the bug is. And I don't even have to touch the production site. I don't have to do anything to get a debug build. I don't have to put a debug build on a production site, let's say unobfuscated JavaScript or unminified JavaScript, in order to use Firebug to debug it. I can debug in the original source code, which I think is really, really powerful. So let me go back to the presentation. So let me just mention sort of an analogy. Hosted mode is really complicated. I don't even fully understand how it's implemented. But by analogy, I'll compare it to Grease Monkey. Is anybody familiar with Grease Monkey in Firefox? Yeah. So Grease Monkey kind of allows you to inject JavaScript in the page. You can kind of like, when a page loads up, you can basically intercept stuff and inject your own modifications to the DOM. And hosted mode is like Grease Monkey, but instead of injecting JavaScript, it injects Java. It doesn't really inject Java into the page. What it does is it kind of intercepts the attempt to load that obfuscated precompiled JavaScript with callbacks into the VM, where that same code in its original Java form is being executed in the JVM as bytecode. So that's how I was able to step through it like that. So it's a really, really powerful tool. It allows you to basically make changes in Java and hit reload and have them show up instantly without even compiling. So because that's a major complaint a lot of people who use dynamic languages have. They're like, well, I don't like a build process, right? I go into, if I'm using like Python or Ruby or something like that, or I'm using JavaScript, I make a modification, and I hit reload, and I see the changes instantly. I don't have to run Ant or run Maven and wait like 50 seconds for it to build and then deploy the ward and do like that stuff. So they want instant turnaround time, and that's what hosted mode gives you. Okay, so let's talk about performance. You wouldn't want to use jQuery if the performance of running these selectors was poor. And so you might have concerns about that. And a lot of people have had concerns because the original selector implementations were written using JavaScript to parse the CSS selectors and executing it in JavaScript. It turns out all of the HTML5 browsers, in fact, including the non-HTML browsers like IE8, have selectors implemented natively now. There's a function called query selector all, so you can basically just ask the browser to execute the selector. However, for other browsers, like on some mobile phones in IE6 and older versions of Firefox and Opera, you still need to have an alternative. So I'm going to show you a benchmark. Now, there's this benchmark that jQuery and MooTools and Dojo often use called Slick Speed. It's a selector engine benchmark. And it's used to, sort of see how they compare to each other, but also sort of to improve their performance over time. And I sort of modified it a little bit and added jQuery to it as one of the benchmarks. And I changed the visualization, so rather than just being a table, it's a horse race. So I'll be honest with you up front, this is not rigged. I may not win. Sometimes it's pretty close because the selector engines in these other libraries are very, very well optimized now. So it's really hard. And if I do win, it won't be by much. However, I hope you guys are going to root for me because I don't want the GWT team to be angry with me if I put up a poor performance. So let's click Start Race and see what happens. Oh, by the way, down here is a table of the selectors being run. That's from the Slick Speed benchmark. So here we go, and we're off. So let's see. It looks like they're running neck and neck here. GQuery is pulling a little bit ahead, but they're still sort of close together. Looks like Dojo is catching up a little bit, at least to me. It's getting close. Okay, come on, GQuery, come on. Yes. Bruce and the GWT team are not going to kill me. Oh, he came back. Dojo came back at the end. Whoa, that was close. I counted my chickens before they hatched there. So, but if you want to see how close it actually is, look at the bottom row, the total row at the bottom. 9.26 milliseconds versus jQuery, which is 10.2 milliseconds. That's about 1 millisecond difference. So that's very, very close. And the reason why it's so close is because they're delegating most of the implementation to the native browser query selector engine. And a lot of the performance improvements we get probably come down to some stuff the GWT compiler does. However, let's go back to the presentation here. There is the subject of IE6, which I refer to as the dreaded IE6. From now on, that's what I'll refer to it to. And unfortunately, I don't have like a VM on my Mac here to basically show you IE. Maybe fortunately, I don't have any way to run IE6 here. However, I did take a screenshot from a PC, and as you can see, running pure JavaScript, the pure JavaScript selector engine, the difference is more substantial. We win by a pretty good margin there. If you look at the bottom line, about 500 milliseconds for jQuery versus prototype 3,800 milliseconds. Or against jQuery, 655 milliseconds, maybe about a 40-50% improvement. It's pretty good. I don't want to toot GWT's horn too much, but that's a pretty good result. What about size, right? I mean, how big is the output of our GQuery library? You don't want a really bulky library. You don't want to download 100K of JavaScript code to implement these selectors. And it could be, we're generating JavaScript from Java, so maybe it's really bloated. I mean, it's not as good as hand-coded JavaScript where you can do a lot of tricks. Here's an example. This is a one line of code from jQuery. It's $div.note. Find all the note elements, the class equal note elements in the page, and replace their inner text with hello Google I/O. So the jQuery library is about 10,000 lines of Java code. It's 300 kilobytes of source on disk. So what would be the compiled JavaScript output? 15 kilobytes or larger, maybe. So the size of jQuery is about 15 kilobytes on disk. I think 1.3 is a little bit bigger, like 21 or something. What would you say about 7 kilobytes, a 50% reduction? If I came to you and said, hey, I got this C++ compiler, and it will produce executables for you and your customers that are 50% smaller, I mean, would it be something you'd be interested in buying or trying out? I think that's pretty good. But it turns out the actual output from that compile up there, 760 bytes for Safari. That's... Thank you. Well, thank the GWT team for that one. So the interesting thing is that's the Safari version where it can delegate to the native selector engine. That's a reduction from 300 kilobytes of source down to the obfuscated output of 760 bytes. So that, I don't know what's the calculation there. It's like a 300 to 1 reduction in size. It's pretty amazing. And even versus some of the other libraries, it's pretty substantial. It's actually smaller than the HTTP headers used to fetch it. So if you were to fetch this code, it's actually smaller than that. Here's like another way to visualize it. Actually, I didn't get to do what I wanted for this presentation, but if you UU encoded it or base64 encoded it, it actually fits on a T-shirt. I wouldn't want to calculate how many T-shirts it would take to put some of the other libraries on there. You might have to visit an outlet store. So you might be wondering like how it is that this can be possible. And I'll try to explain a little bit about like how it works. So one of the advantages we have with GWT is we have a compile phase. So we can parse and run selectors at runtime like the other libraries do with JavaScript. But we can also pre-compile the selectors at compile time. So when it's compiling to Java to JavaScript, it can also compile the CSS selectors to JavaScript. So we can omit the parsing step that the other libraries have to deal with completely. So that code doesn't make it into the output. Also, we can inline functions. So a lot of stuff in JavaScript impacts performance, like making a call that's polymorphic, like up a prototype chain, actually has performance implications. It turns out having like global functions on the window objects, global scope is pretty fast. And then on IE6, there's a bunch of other stuff that the GWT compiler does that I don't want to get into, but it really helps IE6. But the core reason why it's so small and fast is that only fields and methods that are referenced are actually emitted in the output. So typically with JavaScript, you might have a library and you have like 50 JavaScript functions in there. You have no idea which ones are going to be called and which ones won't, so you just include all of them in the whole library and deploy with that. But what GWT does is it says, hey, you know what? You only use the text function to replace inner text. So I don't need the special effects framework, the animation framework, the click handler stuff. It just throws all that stuff out the window, and it only emits the code that you actually use. So like I said, GWT or GQuery has this concept of compile time selectors. It can also do runtime selectors. So you can write $ in a query expression, and it will parse that at runtime. If you do that, the GWT compiler will be forced to include the runtime parsers. It will say, hey, you're trying to evaluate a selector at runtime. I need to go pull in all that code to parse CSS selectors and evaluate them. So you might want to do that when you're first prototyping the application. But then later on, you might want to go, okay, I'm going to make my application smaller or download faster. You go back and you can refactor those into compile time selectors. And the way you do that is quite simple. So if you've used something like the GWT image bundle before, it's kind of similar. But what you do is you make an interface. Here I have public interface slide, and I extend another interface called selectors. And then what I do is for each selector that I want to run, I declare a method. So here I have a method called allSlideBullets, another one called SlideBulletsContext, another one called allSlides. And then you use a Java annotation at selector to tell it that, okay, when you call allSlideBullets, I want it to actually return the result of executing div.slide space li. Then you hand this off to the compiler, and the GQuery library takes over and uses a feature of GWT called generators. And it will parse that div.slide li at compile time. It's like a compiler plugin. And then generate code that actually implements that all slide bullets function. So no parsing code actually makes it into your output. You might be wondering, what happens when you call $selector? Well, there's another feature of GWT called deferred binding and permutations. This might have been discussed in some of the other presentations, but GWT compiles a separate version of the output for each browser. One for Safari, one for IE6, for example. And that means that, for example, the Safari users don't have to download all this bloated code to implement selectors that IE6 needs, because it has native acceleration for selectors called Query Selector All. So it just leaves those out. But on Firefox 2 and older Safari browsers, they don't have Query Selector All, but they do have XPath. They have this function called document.evaluate. So for those browsers, what happens is at compile time, it will parse the CSS2 selector and then translate it into an XPath string. And then it passes it to document.evaluate. So it produces one line of code to implement the selector. Document.evaluate, quote, and then some XPath. That's all it does. And then for all the other browsers, of course, like IE6, it just uses lots of regular expressions to parse the selectors, and then emits a bunch of DOM calls directly into the output, like get elements by tag name, traverse to children, check to see if they have the class that you're trying to match, and so on. Compile time selectors do another cool thing, is they can short circuit stuff, even with the native Query Selector All. I've benchmarked this, and it turns out, for example, that get element by ID is still faster than calling Query Selector All, probably because they don't have to parse anything. So, for example, if you use a selector like # and then the ID of an element, the compile time selector will not omit Query Selector All with like the # foo, for example. Instead, it will delegate to get element by ID. So it'll just produce, get element by ID # foo in the output. And if you have a browser that has this function called get elements by class name, it will delegate to that. Otherwise, it will fall back to the native selector. Because get elements by class name seems to be faster than Query Selector All 2 if you're just doing a class name lookup. And on Firefox 2 or the XPath-specific browsers, it basically has that same short circuiting. It will short circuit for IDs and some other particular queries. And then even for the dreaded IE6, it will generate inline calls by parsing the CSS selector and generating inline calls to DOM methods like get elements by tag names. So it kind of unrolls everything. That's how we get our speed. And it's possible to short circuit or eliminate some of the cases. This is the most immature part of jQuery. So even though we're performing well ahead of the other libraries, in fact, believe it or not, there's a lot of overhead left. So when I get to the end of the presentation and talk about how you can contribute to the project, I'm accepting patches because there's a lot of stuff we can do to speed it up even more than it already is. OK, let me show you a real app. This is the Partusa Open Social container. It's an Apache Shindig reference implementation, and it uses jQuery. So I'm going to show you how to take something that was written in jQuery and do the jQuery equivalent. So here we go with what it does is over here on the left, there's like a navigation bar. And when you hover over these LI links, it puts this little gradient background on it and then makes it clickable. Because normally it's just like an LI link. And here's the jQuery code to do that. My time's getting a little bit short, so maybe I'll speed up a little bit. It basically targets the LI elements there in that really long selector, and it calls a jQuery function called hover. The hover is an interesting function. What you do is you pass two callback functions to it. One to call you when someone hovers the element, and one to call you when they leave the unhover the element. And you can see what they're doing in the callbacks is they're saying if you hover it, add this class called UIStateHover to the element, and if you you stop hovering, remove that class UIStateHover. So here's what the same thing looks like in jQuery. So we have the same selector, and we have the .hover function, and then what's that? Oh, no, it's an anonymous inner class. So one of the things you're used to if you're using JavaScript is that you have closures. You can pass little function snippets very easily and very succinctly into methods. But Java doesn't have first-class functions or high-order functions. It only has anonymous inner classes. So this is how you would normally do it, and jQuery fully supports this programming model. So here I'm passing 2 anonymous inner functions, like new function, and then basically it's the first one's adding the class UI state hover, and then the second one's saying remove class UI state hover. But I thought that this experience would turn off some people who are used to the jQuery programming model. They don't necessarily want to write all this boilerplate Java code. They're usually sort of griping about it. And maybe there's a way to sort of get that feel in Java using some tricks. So here's what I came up with. Lazy evaluation. So what you can do is you can call this function called lazy. And what it returns is a lazy version of the jQuery object that implements the jQuery API. Now, the thing about the lazy version is this, is when you call methods on it, like add this class, or set this CSS property, and so on, it doesn't execute it right away. It just records the fact that that's what you wanted to do. Then at the very end, when you call end, it actually processes all of the things that you queued up and turns it into a closure and passes it to the requisite library function. So in this case, you can just say lazy.addClass.end, and then it's almost as like passing a closure in JavaScript. And if you look at the bottom, here's the sort of the mnemonic. Lazy is equal to function, open close brace, curly brace, and end is equal to close curly brace. And if you count the number of keystrokes, it's actually more succinct than JavaScript. So I told you I would show you some cool tricks with Java. So, okay. Here's another thing. I admit this part's actually not fully baked. I'm sort of still in the process of figuring out exactly what we're going to do here. But I thought about one of the cool things is that since we have this information in compile time selector interfaces and in other parts of the Java type system, wouldn't it be cool if we could auto-generate Java doc-like stuff, but for the designers? So like for the guys who are editing HTML but not writing code, right? So what we want to do, basically, is we want to look at that selector interface that has all our compile time selectors, and we want to produce like a human-readable thing that says, if you want to make something a slide bullet, you have to basically put a class equals slide bullet or something on it, right? So it will sort of document the selector for the guys who are going to be applying it to the HTML. So this is what it would look like. This is that selector you saw before with all slide bullets, and it has the @selector annotation saying run div.slide.li. And then what we do is we add 2 extra annotations. One is @the design name to give us a more human-readable thing instead of all slide bullets. And then we give it a design sample, which is like what a fragment of HTML would look like that this selector would typically target. And then we run our build process on it. We compile our JavaScript. And what will happen is we'll get some documentation output that might look like this. And of course, it kind of looks not too good right now. This is like a prototype implementation, but it's like a table, and for each design element, like slide bullet, you see what is the selector that thing is looking to target, and some Java doc that kind of explains like slide bullets are li items with a UL that you want to appear as animated bullet points triggered by a space or bar or mouse clicks. And then underneath it includes the sample, which is class equal div class equals slide UL, li, and so on. And the idea here is that the programmer would be able to hand this document to a guy who maybe only knows HTML and CSS, and that guy could know what he has to put into the HTML to trigger that jQuery library code to target it and progressively enhance those elements. So it's still something that's in the process of being designed, but I think it has potential. Okay. So plugins. I mentioned that plugins are a really powerful mechanism that jQuery uses. So obviously, we have to do the same thing for jQuery. However, the way plugins work in jQuery leverages sort of a powerful facility in JavaScript, which is prototype modification. So if you include a plugin in jQuery, it modifies the methods on the jQuery object itself and adds new methods to it. And we obviously can't do that in Java. It's a statically compiled language. You can't add methods to the class at runtime or even compile time. I mean, you can subclass it, but so how do we get around that? So what I did is I came up with this mechanism of using some trickery with Java generics. So all you have to write is .as, and then you write the name of the plugin. So here you can see a thing that says as effects, right? And once you do that, the new methods that are in that plugin sort of materialize on a subtype that comes out of that So you see that the pop-up saying that there's a fade-in method, a fade-out method, and so on. So I'm going to give you an example of a plugin I wrote, or not that I wrote, that I ported, called the jQuery star rating plugin. So here's an HTML Web 1.0 page. It has some radio buttons on the right and left here, so on the right. And this could be like a rating thing for a form. Like maybe it says at the end of a document, how would you rate this article from 1 to 5? And you have like 5 radio buttons there. And then you would submit a form to the server to submit the result of you filling out those radio buttons. But we want to progressively enhance that so it's done on the client side and it looks nicer. So I'm going to click this button down here that says Enhance, and it turns it into stars. So now I can mouse over the stars like that. I can click to set the rating. The interesting thing is that it's actually reflecting the click on the star in the underlying HTML form. So if you were to submit this using a regular form submit, the server on the back end that's written in PHP or Python or Java, whatever it is, would get that rating value as a regular form submit. So the code for that looks like this. Oops. GWT, let's see here. What's the name of that function? Plugin module. Okay, so here it is right here. Oops, no, here it is right here. Sorry. This is like a callback when you click the Enhance button. And all it does is, this is the line of code, one line of code. Whoops. Where'd it go? Okay, give me a second. Okay, this one line of code right here, I'll highlight it for you, is all I had to do to activate the plugin. I said $input, which is a CSS selector, runtime selector, says find all the input elements in the page, which all happen to be radio buttons. And say as ratings, so that's the ratings plugin, and then execute the rating method. And that's sufficient. It executes the plugin, it goes to the page, and runs jQuery code to progressively enhance it. So it's really simple to write plugins. So if you're interested in doing it, and I would encourage people who are interested to contribute plugins to me because I need the help, you only have to do 4 things to implement it. First, you write your plugin class in Java, and you extend the jQuery object. Second, you implement an interface called plugin that's parameterized by your class type. Third, you have a static initializer on your class that invokes GQuery.register plugin and passes your class. And then last, you put a static variable on your class. Typically, you name it the same as your class so that people can use it as a succinct way to refer to the plugin. So they can say as, and then like effects or star ratings or whatever. And they can statically import it so they don't have to write like com.foo.bar.star rating. They can sort of import it and just use a very succinct label. So it's being released as open source today. You can go to GWTquery.com and download it. It's still sort of beta, but it mostly works. I'd encourage people to download it, try it out, and help me fix it up. Contribute to the core, write plugins, give me feedback. And before I go further, I'd like to thank, I don't know if he's here today, but someone named Manuel Carrasco, just like two weeks before I started doing this for the show, submitted me like a massive patch. He did unit tests for like half the functions. He wrote documentation. It just appeared out of nowhere as a lifesaver. So I'd like to thank him wherever he is for the patches. I've integrated them with jQuery, and I'd encourage more people like him to come forward and help us out. And I'd encourage you to follow my blog in the future, timepedia.blogspot.com, where I frequently talk about these things. So we're getting to the 10-minute mark. I have time for questions. If you want to ask me a question, come to the mic. Thank you.
Looks great. Looking forward to using it. Glad it's open source now. Can you comment on the other announcement I heard, I think yesterday, about the GWT team bringing this into GWT?
Yeah, you'll have to ask Bruce and some of the GWT team more about this, but they would like to, and I think at the current stage it probably is a little rough around the edges for that. But I think, and I would say this in general for getting anything into the GWT trunk, is that you should join the GWT contributors list. If you got some kind of cool new feature you want to add to GWT, make a project on Google Code or put it into the incubator. Have people use it, test it out, see what needs to be changed to make it more usable or fit more use cases. Get it to a point where it's more mature and reliable, and then it probably will make it into the trunk. They're very open about accepting stuff into the GWT trunk. There's been a lot of contributors, and I hope that at some point in the future, it will be in the GWT trunk, maybe 2.0. Next question?
Hi. Regarding the benchmark, what versions of libraries of Dojo, Prototype, and
the
jQuery?
Newest. Prototype 1.6, the very latest Dojo as of whatever it was last week, and jQuery 1.3.2. I can check. Actually, I have them sitting in my IDE, so I can tell you what the versions are. So let's see here. jQuery 1.3.1, Prototype 1.6.03, and whatever, I think Dojo is called Dojo, but maybe there's a version string in there. I don't know what version this is. It's whatever the latest version of Dojo is. It's this one with the Sizzle engine in it.
All right, thanks.
By the way, just to mention, the slick speed benchmark that I used is an older version, so they added more selectors to it. So, the results might be different if you use the newest slick speed, which uses a lot more varied selectors. Next question.
What is the GWT using to detect the browser?
Okay, so the way GWT works is you can use either browser sniffing or capability detection. You can do either one. So two things are going on. One is that there's browser sniffing for like IE, Safari, and so on. And for each, and that's done by this very small startup script that sniffs the browser and then loads up which compiled version for which browser, like loads up the IE6 version of its IE6. That's one way of doing it. The way I did jQuery is I did a capability detection. So you can write what's called a provider in GWT, which participates in the startup bootstrap process. And what I do is I check like document.querySelectorAll. If it's there, I load up the querySelectorAll version. Or document.evaluate, then I fall back to XPath. And if neither of them there, then I load up the one that's JavaScript. Next, any questions? Okay, so there's a little bit of administration here. Don't forget, and I want to encourage you to basically complete the survey and sort of evaluate the session. There's the URL for it, haveasec.com/io. So please take the time to do that. Thank you very much.